All right, in this clip, we're going to go through the Unit 5 review worksheet. Sorry this is late. Had a little technical difficulty last night, and it got the better of me, so hopefully better late than never. So we'll go through these one by one, and our first problem has an 80 kilogram water skier being pulled by a boat, force of 220 newtons, causing the skier to accelerate at 1.8 meters per second squared. Find the drag force of the skier. So remember the steps. It's going to be at the top of your test. It's at the top of this worksheet. First thing, draw a force diagram. Okay, so we have force diagram for the skier, and skier has got weight, is force due to gravity, and we can calculate that as 80 kilograms times minus 9.8 newtons per kilogram. And if I run that through the calculator, 784 newtons. All right, I'm going to have a normal force going up. And because the skier is not accelerating any direction, let alone up or down, we know that the forces going up and down are equal and opposite. And so from that, I know that the normal force is, 784 newtons. All right. The other things that were given here, we have an acceleration value. That's 1.8 meters per second squared. And we have a tension force. The boat is dragging the skier. I'm just going to call this force tension. You could also call this force skier rope or something like that. And we know that that tension force is 220 newtons. Okay. The force going to the left, the friction force, is not going to be as large. And the reason I know that is because the skier is accelerating in a positive direction. So I know that the tension force is bigger than the force of friction. I just don't know by how much yet. So I'm going to use the force equations up above on the top of the page and the motion equations to figure this out. And really, to be honest, we're mostly going to be in the force equations. So remember that the sum of forces in the x direction, and we're only really concerned about sum of forces in the x direction here because it's accelerating in the x direction. Those are equal to the tension force plus the friction force. All right. And just for clarity's sake, the drag force, that's the force of friction. Funny. So that's what we want to find. We can find that by rearranging this. So the force of friction is equal to the sum of forces, because that's everything added up, minus the tension force. All right, so I'm good there, except I don't know this value. So I need to calculate that. So let's do that over here, because the other thing that the sum of forces is equal to is mass times acceleration. And I do have both of those. Mass is 80 kilograms, and acceleration is 1.8 meters per second squared. And that's going to give me sum of forces in the x direction of 144 newtons. So when I add Ft and Ff together, they add up to 144. So just intuitively, I can look back at this and at this 200 newtons, and that 200 newtons, 220 newtons, is 144 bigger than the force of friction. So I can just subtract that from there and figure out the force of friction. But let's go ahead and plug it into the formula here. And the formula then is 144 newtons minus 220 newtons. And that's going to give us a tension force, or a drag force, of minus 76 newtons. And there is our answer. Okay, so we started out, we're trying to find the friction force. We've used this formula, realized we needed the sum of forces, so then I went here. And then once I got this value here, I brought that back to to this formula here. Number 2, 2,000 kilogram car is slowed down uniformly from 20 meters per second to 5 meters per second in 4 seconds. Determine the average net force in the car during this time. Also determine how far the car traveled while slowing down. So let's go ahead and follow the steps here. Draw a force diagram with numbers. All right, much as we can. So I got a car. It's got mass, so it's got weight. And so I'll go ahead and put that in and figure it out right away here. Oops, some problems on 2,000 kilogram car. Times minus 9.8 newtons per kilogram is going to give me an overall weight of 19,600 newtons. I'm going to have a normal force, and the normal force is going to be the same and opposite, to the same in magnitude and opposite in direction. So that's 19,600. So, what I check for here, are there going to be more arrows going upward or downward? Nope, just one up and one down. And is it accelerating in the y direction? And the answer to that is no. So I know that up and down are going to be equal. And then I'm going to have this car slowing down. So let's just have this going to the left, and the braking force is a friction force. Okay. So I want to know how far it goes. So that's what I'm looking for. Okay. So what do I know? I know that the initial velocity, sometimes it's VO, sometimes it's VI, that's equal to 20 meters per second. That's given. So this is something else you should be writing down. Write down the givens. The final velocity is 5 meters per second. So the car is slowing down, and time equals 4 seconds. So I want to determine average net force. Okay, that's this. So that's going to be in the x direction. I want to know that too. So those are the two things I'm trying to find. First, I want to find the average net force, and then how far is it going. All right. So probably the first thing I'm going to do here is just remember what everything's equal to. So I want to find the sum of force at the x, and that's equal to 2 things. It's equal to all of the forces in the x direction, and it's only one thing on this problem. There's only the force of friction. And it's also equal to mass times acceleration. And so I'm going to use kind of those back and forth here. Okay, so in order to do this, I need mass, and to find acceleration, I need mass, and I need sum of forces. And, to find sum of forces, I need mass, which I have, and I need acceleration. And acceleration, if we think a little simpler, remember that acceleration is meters over seconds over seconds. So if I go back up and I look at my velocities, those are meters over seconds. If I put those over seconds again, that's an acceleration. So it's basically this. It's the change in velocity over the change in time. And what does that mean? Well, how much did the velocity change? It went from 20 meters per second down to 5. So I'm going to put the final velocity minus the initial. That's the change in velocity over the change in time, which was 4 seconds. And so from that, I'm going to get that the acceleration is minus 3.75 seconds, or meters per second squared. That's how much it's slowing down. All right? Now, from that, I'm going to go over, I've got the acceleration, I can go find the unbalanced forces, and using the force equals ma equation. So that was 2,000 kilograms times minus 3.75 meters per second squared. And that is going to give me a force of minus 7,500 newtons. All right. So now I know the thing that forces there is minus 7,500. So then I got to go back up into my motion equations. I need to find, so this is our first equation. This is our first answer here. And now for the second part of the answer, we want to know how far the car traveled while slowing down. So I need to go up and look at my motion equations. I need to find one that has x in it. And both the second formula and the third formula have x in them. The second formula is x equals 1/2 at squared plus VOT plus x0. Okay. I could use that. I have a, I figured out a, I have time, I have the original velocity, and the original position we would just assume to be 0. Okay. The other formula I could use, I'm going to use this one because it's a little harder if you decide to use this one, is to use VF squared equals VO squared plus 2A delta x. Okay, so let's go ahead and do that. And to plug that one in, I'm just going to change colors here so it's a little easier to follow where I'm at on the screen here. So the formula I'm going to use is VF squared equals VO squared plus 2A delta x. And I'm going to plug the numbers in then. So what I've got is 16, oh, I'm sorry, 25. So 5 squared, that's what VO is 25 meters squared per second squared, I have to square the units too, equals 400 meters squared over seconds squared plus, and then 2 times A is minus 7.5 times delta x. Oops. Let me go back and put the units in. Meters per second squared delta x. Okay, so what I want to do is I want to subtract 400 from each side. That will take care of that on the right side and the left side. So 25 minus 400 is minus 375 meters squared over seconds squared is equal to minus 7.5 meters per second squared times delta x. So what we're going to do is divide both sides by 7.5 meters per second squared. And I'm going to end up with a value then of about 50 meters is equal to delta x, and that's the second part. So 375 over 7.5 will be 50 meters, and that's the second answer. So again, what we did here is we're looking for x, and we're looking for the average net force. And so we started trying to find the average net force. That's basically the sum of forces. And we're looking in the x direction because that's how it's accelerating. And the only force in the x direction is the force of friction. That's equal to mass times acceleration. We figured acceleration just by the change in velocity over time. That put us here and gave us an acceleration of a equals minus 3.75. That we could put back in to this formula right here, which we did here. And we took our 2,000 kilogram mass times minus 3.75, came up with a sum of forces of minus 7,500 newtons. Then I went to look for a formula that had x in it, and again, we could use either the second or the third. We have all the variables for both. I just chose one and plugged in the values I had and solved for delta x, and I came up with 50. In number 3, we've got a 70 kilogram box pulled by a 400 Newton force at an angle of 30 degrees to the horizontal. Coefficient of kinetic friction is 0.6. Determine the acceleration of the box. Okay, so start out with a force diagram. Add a box. I'm going to switch back to black here. the box. Okay. Got force of gravity down. Got the normal force going up. Got a force going up at 30 degrees. And that's pull force or tension force, or you could say force on box by rope, if you're going to do the on-bys. And that's at 30 degrees to the horizontal. And then there's going to be a friction force. So what do I know in this thing? I know the box is 70 kilograms. Okay, and I'll go ahead and figure out the force in that so we can get the weight. Force due to gravity times minus 9.8 newtons per kilogram is going to give us a weight of minus 686 newtons. Okay. Now I can't say that that's the normal force now because we've got this tension force that's going at an angle. And part of that is going up and part of that is going to the left. So I can't just duplicate those. The other thing that's a problem is that this box is accelerating. And so the forces aren't balanced from left to right either. Okay, so our second step is break the forces into angled components. And so what that means is we're going to take and use SOHCAHTOA on this force here to get the Ft in the x direction and the Ft in the y direction. Okay, so this one, I'm just going to take this up and work in the space here. So Ft y, okay, is the opposite side, so that's going to be sine of 30 times 400. I forgot to write that in there. So it's a 400 Newton force. And if I kick that in, the sine of 30 is 0.5, and so this is equal to 200 newtons. This is 200 newtons. Okay. The other side, Ft of y, or Fx, I'm sorry, this was Fx of y, Ft of y. I've got that's supposed to be a t right there. For the x direction, we'll just work right below it. So Ft y is equal to cosine of 30 times 400 newtons. And that, if I key all that in, is going to come out to 346 newtons. And remember, this is going to the left, and we're going to make that a negative. Kind of like we made the 686 for the gravity force negative because it's going down. And again, the friction force is not the same as Fty because it's accelerating. So we have to go back and figure those aspects of it. I'm going to go ahead and put that 400 in here that I forgot. All right, so things we know. M equals 70 kilograms. Okay. Coefficient of friction is that funny U. And we'll put a little k there because it's kinetic friction or moving friction, and that's 0.6. And then you look at, we have one formula up above that uses that, and it says that the friction force is equal to mu times the normal force. So now it's important that we do this. Now, how are we going to figure that out? Well, we can use the sum of forces formula. Sum of forces in the y direction equal Fn plus Fg plus Ft in the y direction. So we want to know, and by the way, it's not accelerating in the upper direction, so it's equal to 0. So I'm just going to go back and I'm going to solve that. And essentially it's this, the opposite of Fn. If I set the sum of forces in y direction to 0, and I solve for Fn, is equal to Fg plus Fty. And then I'll just have to take the opposite of that when I get down. So 686 newtons for Fg. Fty is 200. Don't forget the signs. And so that's minus Fn. And so Fn is going to be 486. When I added these two here up, it came up to minus 486, but that's the opposite of Fn, so Fn is the opposite of that. So Fn equals 46. that, I can use the friction formula with mu, and that was 0.6. 0.6 doesn't have any units, times the gravity force, or the normal force, I'm sorry, and that's 486 newtons. And that's going to give me friction force of 292 newtons. 292 newtons. All right, now we want to know how fast is this box accelerating? Okay, and so once I've got the friction force and I've got Ft in the x direction, I'm going back here and I mislabeled this. Ftx, I know those. Oh, I did have the minus there, sorry. So what I need to do then is solve for that. Okay, so F in the x direction. Keep messing that up. Let's keep it straight here. Sum of forces in the f direction is equal to mass effect acceleration. Okay, and so I want to find the acceleration of the box. That is sum of forces in the x direction over m. Okay, and now that I'm able to do that, I can just go ahead and fill all that stuff in. F of x is equal to the friction force plus Ftx. So these two are the sum of F of x. Okay, so let's go ahead and plug those numbers in. Ft of x is minus 346 plus the friction force, which is 292, all over the mass, which is 70 kilograms. And if I plug all that in, I'm going to end up on top here with minus 54 newtons over 70 kilograms. And that gives me an acceleration of minus 0.77 meters per second squared. Here's my answer for number 3. So, again, steps again. We put in the force diagram. We were looking for acceleration of the box, and that we would normally find with the sum of forces in the x direction, because it was being slid in the x direction, equals mass times acceleration. But to find that, I needed the friction force. And it turns out that the friction force depended on the normal force, because we had a coefficient of friction that was a normal force. So I had to figure out what the normal force was. So that's what all the first process was to go through and solve for the normal force. So I did that, then used that to find the friction force, used the friction force to find the sum of forces, so I could plug that back into the acceleration formula, and it came up with 0.77 meters per second, actually a negative 0.77 meters per second. In number 4, we're on the back, says calculate the coefficient of friction if you push a 700 kilogram car out of the snow-covered parking lot at a constant speed with a horizontal force of 560 newtons. So we start out with force diagram. Okay. We've got the car, 700 kilograms. That's VFG. 700 kilograms times 9.8 meters per second squared is going to give me a total weight of the car minus 6860. The car is going at a constant speed. There is only one force up and one force down, so the normal force is equal and opposite to the force of gravity. So that's going to equal 6,860. We are pushing the car at 560 newtons. pushing, or you could say force on car by person. That would be even better. And we want to know what the coefficient of friction is. Okay, the car is not accelerating, so we know the force of friction is also 560, but in the opposite direction, so it's minus 560. All right. So, what is mu? Okay, so this is moving, so this would be mu k is the force of friction over the normal force. And so it's 560 newtons over 6860 newtons. And technically that's a minus. And so if I take 560 over 6860, then I come up with 0.082, okay? And just remember, this is a coefficient, so there's no sign, and the units cancel out, so there are no units. Probably the simplest formula, or the simplest problem on the whole worksheet. Number 5, we have an elevator problem. Person stands on a scale in an elevator, scale reads 510 newtons while the elevator isn't moving. Okay, remember that's important because when you're not accelerating, the normal force on a scale is equal to your weight. When the scale, when the person's moving, the scale is 625. So it's not the same. That tells us the scale's accelerating. So let's go ahead and do a force diagram for this. So it's person on a scale. Fg is equal to the normal force when person's not accelerating. And so that's equal to 510 newtons. That's going to be downward. So that'd be minus 510. And we want to know what it is when it's at 625. So that ends up being our normal force. This is when we want to know. So what the heck is the acceleration when our normal force is 625 newtons? We needed the force when it wasn't accelerating, so we knew force of gravity. That's why we had that. Okay. So the next thing we do, we got no angled forces. We don't need to worry about that. Write an equation for sum of forces in x or y. This is going to be in y. So the sum of forces in the y direction is going to equal Fn plus Fg. And sum of forces is also equal to the mass times acceleration. Okay, so we're going to use that part later. Okay, so let's go ahead and find the sum of forces. So sum of forces in the y direction from here first is equal to 625 newtons plus a negative 510 newtons. And that's fairly straightforward. Okay, that's going to be a grand total of 115 newtons. So then we want to use this formula to figure out acceleration. And acceleration is equal to the sum of forces in the y direction over the mass. And so that's 115 newtons over the mass, which is something we got to figure out yet. So let's go ahead and do that quick. So, need mass. So the mass is equal to the weight, Fg, over 9.8 meters per second, which is g. And g is just the acceleration due to gravity. It's a very special A. Okay. So we go ahead and we do that. 510 newtons over minus 9.8 newtons per kilogram. And we're left with M. Oops, slid out of the way here. Let's bring that back. M is equal to 52 kilograms. So I'll go back and I'll plug that in back over here. And that over here. 52 kilograms and then that's going to equal 150 newtons over 52 kilograms is 2.2 meters per second squared. And there's our answer for that. And our next to last problem, we're going to use a pulley to lift a 150 newton crate with an acceleration of 1.2 meters per second. What's the tension in the rope? These were simple force diagrams. We've got weight of 150 newtons. Fg was 150. And we've got a tension up. It's not a normal force this time, it's Ft. And so you could do an on-by for that too, and that could be force on the crate by the rope. And we want to know what it is. It's not the same as gravity because it's accelerating upwards. So we have some knowns here, all right? We have A equals 1.2 meters per second squared. We want to find Ft. That's what we're going to find. So we're going to have to use the force diagrams basically here, and the force equations. And remember, this is in the y direction, so same thing we did last time. F of y is equal to, units are a little different, Ft plus Fg. Sum of forces is also equal to ma, and that's where we're going to start. We have mass, and we have acceleration. We have mass as soon as we calculated it, right? So again, mass is equal to Fg over g. G is just kind of an A again. 150 over minus 9.8 kilogram. The top is in newtons, and that's going to give me a mass of 15.3 kilograms, which I can then go back in and put that in up here. So 15.3 kilograms times acceleration, which is 1.2 meters per second squared, and that's going to give me a sum of forces in the y direction of 18.4 newtons. Okay, when I add everything up, I get 18.4 newtons. So what that tells me, because it's a positive number, that Ft is 18.4 bigger than the force of gravity. So you could just take 150 and add 18.4 to it, or we can use the formula, which if we rework this one, we get Ft is equal to the sum of forces, everything added up, minus the gravity force. So that's going to be 18.4 minus force of gravity. Force of gravity is negative 150. So if I do that, I minus a minus, it's like adding it to it, and I come up with 168.4 newtons. Note that that's 18.4 bigger than 150. Our last problem had a little extra information added to it. Ms. Seibel has fixed this again. We used in class 170 grams. This is the upper end of a regulation puck. This is at the lower end. So this was changed since yours was printed. Yours didn't have any mass for the hockey puck at all. We added that. So we gave you 170 in class. And so start with the force diagram. Okay. What's our scenario? 170 gram hockey puck is given an initial speed of 20 meters per second on a frozen pond. The puck slides 120 meters before coming to rest. Okay, determine coefficient of friction between the puck and the ice. So I've got the weight of the puck. I have a normal force on the puck, and those are going to be equal because the puck's not accelerating up and down. And then I'm going to have a friction force on the puck. Okay, so what's my nose? Mass equals 170 grams. So that's equal to 0.17 kilograms. So this is 0.17 kg times minus 9.8 newtons per kg And we're going to get really kind of crude numbers here because they're a little minus 1.7 newtons. And that's going to make this equal to 1.7 newtons. All right. What else do I know? My velocity original equals 20 meters per second. My velocity final equals 0 meters per second. So I got that. And x equals 120 meters. And I can use that as either x, f, like the final, and the initial would be x0 would be 0, x final would be 120. Or I can use this as delta x. How far did it go? I can use it either way. And so what do I need to know? I need to know the coefficient of friction between the puck and the ice. Oh, I need the friction force. I have the normal force. Essentially, I need the friction force. So how am I going to figure out the friction force? Well, I need to go with sum of forces in the x direction. That's the one that's accelerating. And remember, that's equal to all the forces added up in the x direction. There's only one. That's the force of friction. And it's also equal to ma. So in this problem, the force of friction is equal to mass times acceleration. Okay. So I'm going to go ahead and start working on that. My mass is 0.17 kilograms. Okay. Times my acceleration, which is 1.7 meters per second squared. And that's going to give me a friction force of 0.29 newtons. Okay? And so that's my sum of forces. All right. So what's my sum of forces, or what's my movement then? So this turns out to be, this is kinetic because it's moving, is equal to friction force over the normal force. Friction force is 0.29 newtons. Normal force, 1.7 newtons. And that is going to turn out to be equal to 0.17. And that's the answer for the last one. So I missed something. Oh, I missed the acceleration. I just plugged an acceleration in and I didn't give you how I found it. So let's go back and do that, and so we don't have magical things happening. So I needed this. That wasn't the given. And so force of gravity is not the acceleration. I just plugged it in there because they happen to be the same number. So the mass was 0.17 times acceleration. I need to find the 1.7, so I need to show you how I found that. And basically, I just use the Vf squared equals Vo squared plus 2a delta x. Okay, and I plug them in, so it works out to be 0 equals, so it was initially 20, so 400 meters squared per second squared plus so 2a times 120 meters. And so when I simplify that a bit, I'm going to end up with 400 meters squared second squared over, so I'm going to take and subtract those from both sides. So I subtract from both sides, it cancels out on the right side, leaves you minus 400 on the left, equals 2a times 120, so I'm going to take the 2 times 120, that's going to be 240 meters on the left, and that's going to equal a, and 400 over 240 is minus 1.7 meters per second squared. Okay, so we got rid of the magic. So this So that's it.